Hello everyone, welcome to my another AWS Cloud Practitioner series. In this session, we'll explore EC2 instance storage. I've talked a lot about EC2 in a previous video. You can take a look at it if you have missed it. EC2 provides the persistent storage that virtual machines and AWS use to hold operating systems, applications, and data. We'll focus mainly on elastic block store, its volumes, attributes, and snapshots, and then take a look at how Amazon Machine Images AMIs for short relate to those storage components. And these are the contents that we'll cover in this video. So what is an EBS volume? An EBS volume is essentially a network-based virtual hard disk. You can attach it to your EC2 instance in the same availability zone, use it as your OS disk, or store applications and log data. Because it's independent of the instance itself, you can detach a volume from one instance and attach it to another. Very useful for scaling or recovery scenarios. It's also heavily used in database workloads where durability matters. EC2 instances can be of two types of storage. Another one is instance store. Instance store is physically attached to the EC2 host. It's very fast but temporary. When you stop or terminate the instance, data disappears. It's good for cache or temporary data processing. In this image, we have two availability zones within the US East 1 region, the East 1A and East 1B. Each zone contains EC2 instances. You can see them as the orange shape icons, and EBS volumes, the green storage icons. You can see here within East 1A, there are two EC2 instances. The first instance has one 10 GB EBS volume attached, maybe for the OS or logs. The second instance has two EBS volumes, the 100 GB and 50 GB, possibly one for the system and another for application data. Each EBS volumes is tied to this specific availability zone 1A. Even though EBS is network attached, it cannot be directly attached across availability zones. And within East 1B, there's one EC2 instance with a 50 GB EBS volume attached. Another 10 GB EBS volume is shown as unattached. It's still available in that zone, but not in use. And here's a real-world example. Let's say you launch an EC2 instance, for example, a T3.micro running Amazon Linux 2. By default, it comes with an 8 GB GP3 root EBS volume for the OS. You might also add a 20 GB IO1 volume for high-performance data storages such as databases. In Linux, you can see attached volumes using LSBLK. Format them with MKFS, create a mount directory as shown here, and mount them for use. This demonstrates that EBS behaves like a traditional disk, even though it's cloud-based. So each EBS volume has several key attributes. One is size. You can choose from 1 GB up to 16 terabytes, depending on workload. Type. AWS offers several types: SSDs for performance and SSDs for throughput. I assume you know about SSD and SSDs. IOPS, the input-output operations per second, measures how many read-write operations per second a volume supports, and this is critical for databases. Throughput measures sustained data transfer rate. Encryption can be enabled using AWS Key Management Service, KMS, and importantly, each EBS volumes exist in a single availability zone, though you can back it up and restore it anywhere using snapshots. An EBS snapshot. It is a point-in-time backup of a volume stored safely in Amazon S3. When you create one, AWS only saves changed blocks after the first snapshot, which saves time and storage space. This is called an incremental backup. Snapshots can be used to create new volumes or shared across regions or accounts. You can automate snapshot creation using Data Lifecycle Manager or DLM or AWS Backup. which helps with data protection policies. And snapshots may have many practical uses. They provide disaster recovery since you can restore an entire volume if your instance or AZ goes down. They support migration. You can create a snapshot in one region and restore it in another. They can also help in cloning environments for testing or staging. Snapshots are automatically encrypted if the parent volume was encrypted, and lifecycle policies can automatically delete old ones to save cost. Let's move on to AMIs, or Amazon Machine Image. It's like a blueprint used to create new EC2 instances. It contains a snapshot of the root EBS volume along with metadata such as block device mappings and permissions. AWS provides public AMIs like Amazon Linux or Ubuntu, and you can create your own private AMIs for your organization. There are also marketplace AMIs provided by third parties that come pre-configured with software. To create AMI, you first launch an instance and configure it the way you need, installing applications, settings, and updates. Then you stop the instance and create an image through the AWS console or CLI. AWS then creates an EBS snapshot of the root volume and store it as part of the AMI. Once created, you can use this AMI to launch multiple identical EC2 instances, making scaling and recovery much easier. And that's it for this video. I'm going to continue about EC2 storage section in the next video. See you over there. I've skipped small topics while making this video. If you have any queries or want a video on a particular topic, comment it down below and I'll take a look at it. And have a good day or good night, depending on where or when you are. Thank you.